All right, pre-calculus. So these are questions that I'm answering here from 2.2. So these were 4 questions that were submitted in for chapter 2.2 of various parts that were done in 2.2. Question 91 was actually one that was both done in class as well as in one of my previous videos. So I'm going to do it again here, but I please implore you to, before you ask questions, please look at the videos that I already do, because if not, I'm just kind of making the same video over and over and over again for just the same question, because people are not looking at the resources. So please, take a moment to kind of look before you email in your questions. If it's honestly something that I haven't done before, both either in class or I've made a video of, then feel free to ask. That's no problem. I just don't want to keep making the same video on question 91 because people don't bother to look and they want to just have a special video made for them. So, again, please just make sure to look. All right, enough with the rant. Let's go ahead and look at the questions. So in number 20, excuse me. So in number 20 here, we were asked to, much like in the last chapter 2.1, we were given the parent function x cubed. We want to describe the transformation from that parent function x cubed to this. So as I said in actually the last video, this is really a question coming from chapter 1. It's just that now there aren't a bunch of parent functions. We're just kind of focusing on this particular parent function. So again, if you're not understanding transformations, if it's still a mystery to you, go back, look at chapter 1. It is very important you start to really get that down. Okay, and if you have specific questions about it, no problem. I'm more than happy to go back to transformations. I did several videos with that, and there's also the class lessons that you can go back and look at. Look at those first, because that's really what this question's asking for. Okay, this isn't something new that you're learning this chapter. So the transformations that are happening here from the parent function to this, I am moving 2 to the right and I'm moving 2 units down. Those are my 2 transformations that are occurring here. So the -2 in here is telling me I'm moving to the right 2 units, and the -2 out here is telling me that I'm moving down 2 units. So that's me describing the transformations. No particular order. It didn't ask me for that. It's not asking me to make a sketch of the graph. It just tells me describe the transformation. So that's what we did. All right, moving forward, number 29, we were asked to use the lead coefficient test to describe the behavior of the polynomial. So we're not graphing, we're not doing anything extra, we're just asked to describe the behavior. So how do I do that? I need to first determine the degree. So if I look at this polynomial, the highest power is 4. So I'm going to write that down here. So I know that the degree is 4. Okay. Now, the thing that has the highest power, I look at its coefficient. So in this case, it's 2. So the lead coefficient, which I'm writing as LC, lead coefficient is, I don't really care about the number, I just care more about whether it's positive or negative. It's positive. So when we have an even degree, that means that we're seeing something that is going up to the left and then up to the right. We don't know what happens in the middle, but this is what's the behavior, the end behavior. So how do I describe it? As I was doing in class, and I'm going to always describe it using the math symbols and the math terminology. You are free to describe it in words if you really can't do the math terminology. However, I am cautioning you here, as I've done numerous times in class, you are responsible for understanding. Let me repeat that again. You are responsible for understanding that math terminology. Because if it shows up on a multiple choice, it's going to be written in the same math symbology, and therefore you cannot say, oh, I didn't know what it meant. You'll do fine on free response, but you're going to bomb every time you see it on a multiple choice, just because it's not in the way that you would write it. I'm not asking you to write it this way. I'm asking you to understand what it says. All right, kind of like writing in block lettering or writing in cursive. I'm not asking you to write in cursive. I'm just asking that you're able to read and understand cursive. Those are two different things. Okay, so in this case here, if I'm going to the left, so as x goes, oops, so as x goes to negative infinity, meaning we're going to the left, I'm going to put this in blue here, kind of as the common speak. Okay, so that's what the blue is. The red is the actual correct math terminology. So as x goes to negative infinity, go into the left. F of x, because that's our y value here, f of x is going up. Okay, that's this end behavior. I need to describe both. Now what happens on this side? Oh, okay. As you go in the other direction, as I go to the right, f of x also goes up, like so. That's what these are saying. So common speak in blue, that's what this all together in red is saying. So this is describing the end behavior. And why do I know this? Because the degree is even. It was a power of 4, and the lead coefficient is positive. So this is my reason why. Why is this happening? Oh, because of this. That's what's letting me know what's happening. All right, so that's number 29. Okay, number 55. So 55, we have find all the real zeros of the polynomial function. Determine the multiplicity of each zero, and we're going to use a graphing utility to verify our result. So we're going to find the zeros, meaning we're going to take our equation like we have right now, and we're setting it equal to 0. So as I was doing some examples today in class, you want to start by doing the easiest thing first, which is take out a common factor. Okay, so I took out that greatest common factor. They all were divisible by t. I factored that out. I now have this. This is a quadratic that is factorable. So factors of 4 that give you a -4. Oh, that's -2 and -2. So what are my zeros? What values of t, that's what that means, zeros. What values of t make the polynomial 0? Well, if t is 0, that would make it 0. Here, if t is 2, 2 minus 2 would be 0. And then the same thing would happen here. So I'm not going to say t equals 2 again. I would say t has a, 2 has a multiplicity of 2. So I'm meaning I'm getting that answer twice. Okay, so these represent my zeros to the polynomial. So really, what's the new thing that you learned with regards to finding these zeros? If anything, this multiplicity, but really the factoring techniques, this of how do I factor a polynomial, that is stuff you learned last year. So if you are struggling with this, I don't know how to factor, you didn't teach us that. You're absolutely right. I did not teach you that. You learned that last year from whoever your Algebra 2 teacher was. Okay? So you need to go back and you need to refresh that. And if that is something that you're not understanding how to do, I'm more than happy to help point that out to you, or I'll, for you to, I'll point you to a lot of practice things that you can do, but that is something that, again, I'm not going to be reteaching you in class, unfortunately. This is pre-calculus. This is not Algebra 2 year 2. So this is where you have to be responsible for what you learned last year and kind of retaining that. And if you forgot some stuff, that happens, but it's your responsibility then to kind of go back and refresh that. And if you need places to go to find that, I'm more than happy to help you find those things, like Khan Academy. There's a bunch of free stuff that you can do online to kind of help you do that. But I can't take class time to, hey, can you teach me Algebra 2 all over again this year? Because when you pass this course, that's it. Now you move on to calculus. You can't move into calculus or even to statistics saying, yeah, I just learned Algebra 2 again. Like, then you really didn't learn pre-cal. All right. Now, for our last one, number 91, we're tasked with sketching the graph of the polynomial. So that means we're doing everything that we learned in this chapter. Okay. So we're doing everything. Lead coefficient test, factoring the polynomial, finding the zeros, finding the multiplicities, because we need all that to be able to make the sketch of the graph. So let's start by first talking about the end behavior. So I like to go in like the order in which the book kind of did the presentation of material. So end behavior. So I'm going to start with, okay, well, what's the degree of the polynomial? Well, it's degree 3. That seems to be the highest power in the polynomial. Don't just go with the first thing you see, because sometimes they write the polynomials out of order. So just a little hint, sometimes that happens. So be prepared. You might have to rearrange some stuff. Look for the highest power. In this case, it's 3. Lead coefficient. What's the lead coefficient here? Well, it's a positive 1. So lead coefficient is positive. So what does that tell me about the end behavior? I'm going to draw a little picture here, just like I did in number 29. So it's odd, meaning it's doing something like this. Okay. All right, so that's all end behavior tells me. Okay, let's move on. Now let's try to find some zeros. So I'm going to take my polynomial. And I'm going to try to solve. When's this equal to 0? So again, I'm going to try the easy stuff first, which is there any greatest common factor? No, there isn't. I don't see anything I can factor out of this. So I'm now going to try, there's 4 terms. I could try factoring by grouping, something that I learned, hopefully, in Algebra 2. Okay, let's factor by grouping. So in the first group, I see there's a common factor of x squared. So this is x plus 3. Now when I go to the second group, I want to factor something out that will match something in the first group. So I see that if I factor out a -9, or a -9, sorry, that's going to give me an x plus 3, which matches what I have in the first group. So these two have something in common. So that means we could proceed with factoring, because since they now have something in common, I'm going to factor that out. So taking away the x plus 3 from this one, taking the x plus 3 away from this one, because I'm factoring it out, that leaves you with x squared minus 9. Now this, we can factor even more, because it is a difference of squares. So this will become x plus 3, x minus 3. So now this has been completely factored. I'm going to now write my zeros. So what values of x make the equation equal to 0? Well, when it's -3, -3 again, so that's a multiplicity of 2 for that -3. And then finally, +3. So those are my answers. Okay, so now we did that. We stated multiplicities. Now it's time for us to put everything together. Let's start making our sketch of our polynomial. So just making a makeshift axes here. So when I start to make the sketch, I start with, let me put down my zeros. So I have a 0 at -3. And then I have another 0 at +3. and I label them on my sketch. So again, I'm going to label this. This is a sketch. Now for end behavior, I know that I'm going to start down here and I'm going to end up here. Now I got to figure out, well, how do I draw this so that I'm going through or touching these x-intercepts, because that's what this represents. All right, now this is where the multiplicities come in. Since -3 has an even multiplicity, it's showing up twice, even multiplicity, I am going to be tangent to that point. I'm not going to go through the point. I'm tangent to that point. So let me put the -3 up here so we know what value that was. So I'm tangent to that point. I'm not going through it. I'm just touching it. That's what it means to be tangent. Then I need to go through. So through the 3. So I'm going to go through that point because that had an odd multiplicity. It's just showing up once. So when things have an even multiplicity, you touch the x-axis. You are tangent to the x-axis. When it has an odd multiplicity, you go through the axes. So your book tells you to find some more points. Typically, we would like to, I've talked about this before in chapter 1, when we sketch a curve, minimum we would like to have is 3 points. So right now, I just have the 2 points. I got this at -3 and that at +3. So I'll try to get one more point. So for me, and this is why I don't put a scale on these axes, because this is a sketch, I can then plug in a number. So I'm going to plug in, let's say I plug in x is 0. So if we plug in 0 into our polynomial, I see that at 0, it's -27. So you see where I have it crossing through the y-axis? Yeah, it's somewhere down here. I can label that point and say, oh, this is at 0, -27. Because since I didn't put a scale yet, I didn't say how much each tick mark was, it makes it easier for me to just kind of label the point. So this is why I tell you guys, label the points. Because if not, then if you're not labeling, then guess what? You're having to spend time, letting me know what the scale is of each tick mark. But if you label the points, it just makes it so much easier and less work for you, because I now have the exact information. Here's where it's crossing through, Mr. Sardui. Okay, got it. Perfect. But if you don't put those there, then what do I have to go off of? I just have to count the tick marks. And I don't know. If I count the tick marks here and you didn't tell me what this is, that looks like -3. Oh, I meant -27. Well, where's the scale? I don't see it. Oh, I didn't label the points. I'm sorry. Oh, I'm sorry for you. You're not going to get the points. So label your coordinates. Makes things easy for you. And you get points. So that's it. This is the sketch of my graph. So again, as I mentioned in class, how would these get graded? I look at the end behavior. Is the end behavior correct with what you said? Does it make sense with what the polynomial is? The roots, did you find the correct, whoops, not that one. Did you find the correct roots? So this, did you have the correct multiplicities? How do I know? Because then it should be doing the right behaviors through those points. Is it touching where it's supposed to touch? Is it crossing where it's supposed to cross? And then finally, is it a polynomial that you sketched? So remember, polynomials are always continuous and smooth. So if you were to just kind of like I talked about today, like making this kind of like janky graph because all you're just doing is connecting the dots, this is not a polynomial because it's not smooth. You just drew jagged lines. Same thing like when people do the little parabolas, and I talked about this in the last video, they're doing like this where they're playing like connect the dots, like if they're back in elementary school. That's not a parabola. There's just a bunch of line segments. That's not what a parabola looks like. It is a smooth curve. So you need to make sure that you're sketching a smooth curve. All right, so that does it for this video looking at questions from 2.2. Hopefully you found this helpful, and I will see you guys on the next video.